In this lesson, we're going to be looking at how we can compare fractions and see which ones are bigger and which ones are smaller so that we can put them in ascending or descending order. So since it's fractions, remember we've got a numerator on top, and that's how many pieces we have, and we have a denominator, which is how many pieces would make up a whole. 3/4 looks like this because there are 4 sections altogether and 3 of them are shaded in. We'll also be looking for lowest common denominators in this lesson, and so if I've got 1/6 and 3/8 and I want the lowest common denominator, I'm looking for the lowest number that 6 and 8 both go into, and that is 24. So I can do 4 times 6 would get me 24, must do it to the top as well, and I can get 3 times 8 to get 24, must do it to the top as well. Remember, what we're doing is we're not changing the value of these fractions, we're simply changing their numbers. And so these two new fractions here have got exactly the same value as the old fractions, it's just the numbers are different, and most importantly about the numbers, the denominator is the same. We'll also want to be able to use the greater than and less than symbols, and so there are those two symbols, but which one goes between 8 and 9? Well, there's two ways to remember it, at least two that I know of, two easy ways. First thing you can think about is that the symbol will always point to the smaller number, and the other way to think about it is it's going to eat the bigger number. And so you can either think about it as an arrow, or you can think about it as a crocodile or something with a big mouth. And so I know that the one between 8 and 9 will have to point towards the 8, or I can think about it that it's eating the 9 because it wants to eat the bigger number. Notice that it doesn't matter which way you think about it, the symbol points the right direction that way. We're also going to be converting to mixed numbers, and so if I had 11 over 3 here, that means 3 pieces make up a whole, and I've got 11 pieces altogether. So to make it a mixed number, I have to work out how many wholes there'd be and how much left over. So if I just do 11 divided by 3, that tells me how many wholes there are. It's 3, and the remainder will be what's left of the fraction. So that turns into 3 and 2/3. So remember, just the numerator divided by the denominator. So let's start comparing some fractions. We've got 3/5 and 4/5. So let's draw them out. There's 3/5, 5 sections, 3 of them shaded in. And there's 4/5, the same 5 sections, this time 4 of them are shaded in. And notice that 4/5 is bigger than 3/5. Now that makes perfect sense. 4/5 has got more pieces shaded in. And so when the denominator is the same, whichever one's got more pieces shaded in is bigger. So in other words, whichever one's got a higher numerator is the larger fraction. Knowing that we can just compare the numerators means that when I want to compare two fractions, I don't need to draw pictures of them. I can go, well, the denominator is the same, so which one's got the bigger numerator? That would be the 7, so I can put my greater than symbol in. And then in the next one here, once again, just compare the numerators. This time 2 is smaller than 8, I can put my less than symbol between them. And if I was to look at 9 and 10, it doesn't matter that they're in proper fractions because the denominators are still the same, and so 9 is smaller than 10, so I can put the less than symbol. No need to draw the fractions, just looking at the numerators as long as the denominator is the same. With the next two fractions, the denominator is different, but the numerator is the same. And so let's draw these two fractions and see how we can compare them. So there's the two fractions. Notice I've been careful to make sure that overall they take up the same amount of space so I can accurately compare them. And we notice that 2/3 is bigger. It's got more shaded in than 2/4 does. And notice that even though this one's bigger, the denominator is actually smaller. So the numerators are the same, but this denominator of 3 is smaller than that denominator of 4, even though this is the bigger fraction overall. And the way we can think about that is, imagine these were two sort of, strangely shaped pizzas. The top one is cut into 3 slices and you get to have one. The bottom one is cut into 4 slices, you get to have one. Which slice, which one's going to give you a bigger slice? And it's going to be this one here, isn't it? Because if you take something and cut it into 3 slices, the slices are bigger than if you had to cut it into 4 slices. The same idea that if you have to share something with 3 friends, you're going to get more than if you have to share it with 4 friends or more. And so the idea is, the bigger the denominator, the smaller each slice or each piece is. And so that means if they both got the same number of pieces, like they do here, they both got 2, then it's actually the one with the bigger slices that's the bigger fraction, and 2/3 has got bigger slices because the denominator there is smaller. And so with the same numerator, it's the fraction with the smaller denominator that has the largest value. So let's do some more comparing without having to draw diagrams. And so this fraction here, it's been cut into 8 pieces and we've shaded 5 of them. This one's 7 pieces, we've shaded 5, so we've got the same number of pieces there, but since this one was cut into less, each of those pieces will be bigger. So that means this is the bigger fraction. The one with the smaller denominator is the bigger fraction. So here, let's just compare the denominators. This one's got the smaller denominator. It's going to have 2 pieces, but they're going to be bigger than these 2 pieces there. So once again, this is the larger fraction. And same down here, let's just compare the denominators. This one's only been cut into 10 pieces. This one's cut into 20. So that means that these pieces are twice as big as these ones here. And so that means that these 7 pieces are twice as big as those 7 pieces, making this the bigger fraction. Now, unfortunately, life isn't always simple, and you end up with fractions where neither the numerator or the denominator are the same. So what do? We make either one of them the same by using equivalent fractions. Now what I'm going to do is, since I can do either the numerator or the denominator, I'm going to look at what's easiest. And in here, it's easy to turn 5 into 10 than it is to turn 2 into 3. So I'm essentially looking for the lowest common denominator or numerator. So when you're adding or subtracting fractions, it has to be the denominator, but when you're comparing fractions, it can be the lowest common denominator or numerator. So here I'm going to do denominator, simply because I can turn 5 into 10 really easily. So multiply by 2 on the top and the bottom, and that means I end up with 4 over 10 and 3 over 10, and that means that this one's going to be bigger because it's got more pieces. The pieces are all the same size because the denominators are the same, but this one's got more of them. And now in the second one here, this time if I try and turn 3 into 11, well, you can't do that. That's a bit difficult. But you can turn 2 into 6, which is nice. So 2 times 3 gets 6. So let's times them by 3 on top and bottom. Notice this time I found the lowest common numerator, not the lowest common denominator. And so let's rewrite this fraction here so that now we've got 6 on top of both of them. So which one's bigger? Well, this one has been cut into less pieces overall because that was only cut into 9. That means each of those pieces will be bigger. So these 6 pieces bigger than these 6 pieces. So this is our bigger fraction. Notice I put the greater than sign or less than sign up with the original fraction. We'll see that again in the example. So we can pick either the numerator or the denominator to make the same. Now, unfortunately, sometimes life's really not fair, and 4 doesn't go into 7 and 5 doesn't go into 8. And so from here, it doesn't really matter which one I use. Neither of them's really easier, so I pick one, and so I'm going to go the bottoms, the denominators. So what's the lowest common denominator of 5 and 8? And so what does 5 and 8 both go into? And that's 40. That's the lowest thing. So I turn this one into 40 by multiplying by 5, top and bottom, and I turn this one into 40 by multiplying by 8, top and bottom. And so then I've got my new fractions and I can compare them. This one's bigger because the pieces are the same size and I've got more pieces. I tend to find personally that if it doesn't matter which one to use the denominator, because I personally find it much easier to compare fractions when the denominator is the same, but you might find the opposite. Just do whichever one works best for you. So I can put my greater than sign. This one was bigger than that one. Now when there's mixed numbers, so there's whole numbers and a fraction part, if the whole numbers are different, then that's awesome because that makes comparing them the easiest thing in the world. Whichever one's got the bigger whole number is automatically bigger. Think of it this way. This is 5 and a bit. This one's 4 and a bit. So which one's more, 5 and a bit or 4 and a bit? It's obviously 5 and a bit, isn't it? So that means this fraction is bigger than this one. Didn't need to compare any numerators or denominators or make them the same at all because the whole numbers are different. And so that means that this is definitely the bigger fraction here. If the whole numbers were the same, then I'd start comparing the fraction parts normally. I'd just ignore the whole numbers then and start comparing the fraction part normally. But if they're different, then whichever one's got more wholes is automatically bigger. And for that reason, I find it much easier to convert all improper fractions into mixed numbers when I'm comparing. Now, interestingly, the textbook suggests doing it the opposite way. It suggests changing everything to improper fractions. And it only really uses the lowest common denominator. So I actually think the way we're doing it here is better because it gives us more options, and I definitely suggest always changing them into mixed numbers rather than changing the mixed numbers into improper fractions. So always go towards mixed numbers in this rather than away. So let's take a look at some examples. We're going to put one of the two symbols, greater than or less than, between these two fractions. So we need to write them down first. And even if you could just look at those and tell which one's which, you've got to show your working here. So we're going to show our process. How are we thinking this through? We're going to get the numerator or the denominator the same. Doesn't matter which one. So which is easier, 5 and 10 or 8 and 17? Well, since 5 goes straight into 10, that's going to be nice and easy. And this is where, if you're only focused on the denominator, wow, what's the lowest common denominator of 8 and 17? That's actually pretty hard. But 5 and 10, well, that's dead simple. It's 10. So I'm going to turn 5 into 10 by multiplying by 2. And so I end up with 10 over 16 and 10 over 17. So which one's bigger? It's 10 over 16 because it's got less pieces altogether. So each piece is bigger. These 10 pieces, bigger than those 10 pieces. I go back to my original and I just put the greater than or less than sign, because remember, it was asking me to compare these two fractions, not these two here. So we always write it back between the original two fractions that I wrote down. In the next example, we're asked to place fractions in ascending order. Now, sometimes this is easy because they're not mixed numbers and they're all just proper fractions, and it's easy to get the lowest common denominator, or they're already all the same. That's great. I've deliberately picked a more complicated one here to show you a method of which you can do it when there's mixed numbers and when there's proper fractions and improper fractions all together. And so what we do is we start by writing down the four fractions, and then this next line here, this is where I'm going to change them to mixed numbers. Now clearly, if you don't have any mixed numbers, if they're all proper fractions, you can just skip this line. But in this case, I have a mixed number. Here's one here. If it's already a mixed number, I'm just going to write it down on this line. If it's not a mixed number but is improper and can be changed, I'm going to change it to an improper fraction. That's all I'm going to do. I'm not going to change anything else. These two are proper fractions, so nothing has to happen there. I can just leave them the way it is. Since these are both mixed numbers with two wholes, I'm just going to compare these two separately to these two. I already know both of these are bigger than both of them. And so when I'm looking for a common denominator or numerator, I'm going to focus on just these two first and then just these two second. So let's focus on these two. My next line down is where I'm going to do the common denominator or numerator. And I could do numerator or denominator on this one. Either would be as easy. Since I prefer denominators, that's what I'm going to do. I'm going to multiply both of these by 2 because that'll make the denominators 4. And so I write it down. Now notice I just copied this one down. I didn't change this one again, so I just copy it down again. This one I changed though, so I write down the changed version. Notice that they now have the common denominator there, so I'll be able to compare them in a moment. In fact, I can do it right now. I can tell you this one's bigger than that one there. Now these two, I'm going to skip all the way down to here because we didn't have to change into mixed. I'm going to skip all the way down to this one and get the common denominator, so, or numerator. But 6 doesn't go into 13, 7 does go into 14, so I'm going to multiply these by 2, and so I get 12 over 14. And this one I'm just going to copy into this last line here. I'm not going to change it because now they're both 14. I can compare. Notice they don't all have the same denominator. I don't need that because these two are automatically bigger than these two here. So just comparing these two together and just comparing those two together. And so this one's obviously a bigger fraction here than this one because this one's got more a higher numerator. Now I can write them all in ascending order. Remember, ascending order starts with the lowest of the lot. So the lowest of the lot is this one here. No holes, and it's smaller than the other one with no holes. But I don't write down 12 over 14. That wasn't my original. Always cast your eyes up at the original fraction. So the first one I write down is 6 over 7. And then it was this one here. Have a look up. Well, it's still 13 over 14. So I can write that down. I'm done with those two. Now these two, which was the next highest up? So that'll be this one here, 2 and 2/4, and then it goes 2 and 3/4. So once again, I don't write down 2 and 2/4 though. Have a look up. You got to look in the original fraction. So 5 over 2, write that down, and now I can write down my 2 and 3/4, and I can write that down. let's give some practice questions a go now. Remember to try to lay it out in a nice way that shows your thinking, the way we've gone through in the examples. Remember to pause the video. And there's our solutions. There's the way that I laid out that one in order to show what I was thinking with my mixed numbers and then my common denominators. In the first one, I wrote the fractions down and then I looked for a common numerator or denominator. 10 doesn't go into 19, but 3 does go into 6. And so I just multiplied the top and the bottom by 2, and that meant I had the same numerator, which means that the one with the smaller denominator is actually the larger fraction because each of the pieces would be a little bit bigger, and that means that 6 over 19 was the larger. So I wrote the sign back between the original fractions and I made sure it was eating the one on this side, the 6 over 19. In the second one, I started by writing all the numbers down, all the fractions down, nicely spaced, and then this was my change to a mixed number line. So change this one, changed that one, didn't have to change that one but wrote it down because it was a mixed number, didn't change any denominators or numerators yet. Now let's have a look at them. 3.5 is obviously bigger than 1 and the 1 here, so this is the biggest fraction. I don't need to do anything else with this fraction, it's the biggest. And this one here, the 1/3, that's the smallest fraction because it's got no mixed number. So on the next line down, I did copy the 3.5 and the 1/3 down just because it's nice to have them all on the same line to compare them at the end. And with this one, I was going 1 4/5. I had to get the same numerator or denominator with the 3/10 here. And since 5 goes straight to 10, I just multiplied those both by 2. And so that's where I came up with the 8/10 there. This was my comparing line. 1/3 was the smallest, so I wrote it down. 3.5 was the biggest, and so I wrote it down right at the end. But notice I wrote down the 7 over 2. Remember, you got to go right up at the top. You got to write the original fraction down. And so I had my first one and I had my last one, and I left plenty of space for the middle too. And so now I'm comparing these two fractions, and I know that this one's bigger than that one, which means this one goes next because it's ascending order, and so you go the smallest to largest. So I had to go 1 3/10, look up the top. That's not what it was 13 over 10, so I wrote down 13 over 10, and this 1 8/10 was originally 1 4/5, so that's what I wrote down there. So definitely not an easy question, but that step-by-step process makes it a little bit easier. Here's some more practice questions. If you need to have another go, remember to pause the video. And there's the solutions to those ones. And that's the end of the lesson.